I'm going to do a MANOVA in SPSS as fast as humanly possible, so hold on. Okay, department is IV number 1. It's got 3 levels. Job sharing is IV number 2. It's got 4 levels, right? None, minimal, moderate, maximum. Okay. And I have the IVs marked as nominal and the DVs of job satisfaction and productivity as scales. All right, so assumption number 1 is sample size. So according to the problem, there's at least 5 people per group that got the means, which okays the sample size. All we need is 2 or more, right? It has to be more than the number of DVs. So since we have 5 people per little subgroup, that takes care of the sample size. So number 2 coming up is normality, just on the DVs. Analyze, descriptive, exploring, just the DVs. We're not going to do outliers here. Remember, that's a separate assumption for MANOVAs only. But we are going to do the histogram, and we want the normality plots. That'll give us the Smirnoff test. And I don't think we need any options. Let's click OK. Got 30 in each group. There's the overall mean for job satisfaction, 6.6. Overall for productivity, 5.63. Test of normality. So job satisfaction is okay. Productivity is okay. So normality is good. Let's just take a quick peek at the histograms. That one looks pretty good. A little bit kurtotic, you'd say. And okay, box plot. No outliers. Oops, sorry. And there's our productivity. Again, not perfect, but good enough for a robust MANOVA. And there's the productivity, no outliers. So that's taken care of. On to the third assumption, outliers. Okay, outliers, we have to run the Mahalanobis. So we're going to go to Analyze. This one's a weird one. It's under Regression, Linear. Okay, our DVs, we're going to pretend they're IVs. And that fake DV that we made was the ID number, right? That's just 1, 2, 3, 4, 5. Okay, that's, again, this is the only way to access the Mahalanobis through the SPSS. You go to Save. You click the Mahalanobis. And I'm not going to click the cooks this time. I'm going to click Continue. Okay. So remember, since this isn't a regression, disregard these boxes. The only one you want is the one that says residual statistics with the Mahalanobis in it, okay? And there we are right there. And our maximum Mahalanobis is 5.561. So we have to compare that to a critical Mahalanobis table here. So hold on. We have 2 DVs, which is the number of DFs in this table. So our number of 5 point whatever it was not greater than 13.82. So that means we have no outliers that are going to affect our result. So we're good to go on outliers. The next assumption is linearity. That's linearity between the DVs. So we're going to go ahead and make a chart on that one. We're going to go to Graph, Legacy, Scatter Dot. We're going to do the matrix scatter. Define it. Okay, so the matrix variables, that's going to be our DVs. And our set markers by SPSS can only do one at a time. So we're going to do the department first. Okay. Click OK. Yeah, you could see a definite pattern there. They're trying to form a straight line, so that one's good. So we're going to do the other IV, job sharing. We're going to go to Graphs, Legacy Dialogues, Scatter Dot, Matrix, Define, kick out the department, kick in the job sharing, click OK. And again, yeah, they're pretty darn linear, right? So yeah, that would easily fit a straight line. Don't know how strong the correlation is, but that's coming, okay? So we have not violated the assumption of linearity of the DVs. So moving on. Assumption number 5, we're going to skip. That's the homogeneity of regressions. We're not going to put our DVs in any importance order, okay? We both think they're equally important. So skipping number 5, on to number 6. Multicollinearity and singularity. Okay, so multicollinearity. Basically, we're just going to check the correlations between the DVs. So it's going to go to correlate, bivariate. We're just looking for the DV correlation. So let's put those in there. We're going to get the Pearson's R. Click OK. Remember, the correlations automatically should be somewhere between 0.3 and 0.8. So let's see what ours is. Looks pretty good to me. 0.614, which is well within the range. Okay, so we did not violate multicollinearity, and we did not violate singularity because we did not make a grandiose DV that is the sum of any other DVs. Okay, so we did not turn that into one giant DV. If we did, we would have to run a one-way ANOVA, or just an ANOVA, not a MANOVA. Okay, so we don't want to do that anyway. So multicollinearity and singularity are okay. Let's move on to the next one. Homogeneity of variance covariance matrix. The good news is here that we get to actually run the MANOVA. So we're going to go to Analyze, General Linear Model, Multivariate. Okay. Our DVs are job satisfaction and productivity. Our grouping IVs are department and job sharing. And let's see, model, contrast, plots. What do we want? We always want plots. So let's look at our plots one way, add, and then we'll look at them the other way. This is what's going to give us our graphs of the estimated marginal means. It'll show us where the interaction is, that kind of stuff. And what else do we need? Options, like always, department, job sharing, any kind of interaction. Descripts, effect size, power, homogeneity of variance, click that. And I think we're done. Let's click OK. So to check the assumption of homogeneity of the variance covariance matrix, we need to look at the box M. But in the meantime, this tells us how many are in each group. All right? These are the means, job satisfaction between the different departments and the different job sharing categories. And there's our box's test, his box's M test. So the significant level here, this number would have to be less than 0.001, which it's not. So we did not violate the homogeneity of variance. Yay. So now we can go ahead and interpret this MANOVA, sorry. So this box only looks at the different IVs. It doesn't break the DVs down into any kind of separation. It just kind of treats them all as one. And we can look at it right off the bat here. So from department, there was no significant difference. Job sharing, there was significant difference. And the interaction between which department and which level of job sharing, there was no significant difference. So that's good news, right? And we did violate the homogeneity of variance by M, the productivity, especially job satisfaction as well. Job satisfaction was just barely underneath there. Productivity, it was violated. So we have to put that into our report, okay? But again, this is a very robust test, so we're just going to pretend that it wasn't violated. But on your answer sheet, you're going to have to put that the homogeneity of variance has been violated. And then this is the source of variance table. This is where you would pull your F's and your partial eta squareds and that kind of thing. So the first one is the overall model, and it says yes, there's a significant difference in there somewhere between job satisfaction and productivity. You see how it splits up the DVs, right? Here's the first DV, here's the second DV. So it splits them up. So let's go to the department, okay? There was no significant difference between either job satisfaction or productivity by department, right? No main effect of department. For the job sharing levels, there was for both of them. So there is a main effect of the job sharing when it comes to productivity and job satisfaction. And the interaction box, no, nothing there. Okay. So the only thing that seems to be affecting both job satisfaction and productivity is how long a person gets to job share. It looks like the more they get the job share, the higher the productivity and the higher the job satisfaction. Hoorah! So let's look at the effect size. And it's pretty big. It's about 79%. And our power, again, is really big. It's almost perfect, okay? So that's it. Hope you enjoyed it. MGZ, out.